Have you ever looked at a math problem and just felt like the rules were, well, kind of made up, arbitrary and just confusing? Well, today we're going to pull back that curtain. Turns out there's a really simple, logical system behind it all. It's like a secret code. And in the next few minutes, we're going to crack it together. So take a look at this. It probably seems like a total jumble of numbers and symbols, right? Where would you even start? Well, think of this as our secret code. And by the end of this explainer, you're going to have all the keys you need to solve it with confidence, step by step. All right, the very first key to unlocking pretty much any math word problem is just knowing which tool to use. Should you multiply? Should you divide? Forget guessing. There is one simple question that will give you the right answer every single time. And here it is. This is the foundation. Are you trying to find the total amount of something? You multiply. Simple. Do you already know the total and you just need to break it down into smaller, equal groups? You divide. It's really that straightforward. Okay, let's see this in action. We've got 42 boxes. Those are our groups. And we know there are 15 bulbs in each group. So we're trying to find the total number of bulbs. Since we're looking for the total, what do? We multiply. 42 times 15 and boom, we've got our answer. Now, let's flip it around. Here, we already know the total. The total is that $648 Chris needs for his new guitar. We also know the value of each item in the group, $9 per hour. What we need to find is the number of groups. In this case, how many hours he has to work. Since we've got the total, we divide. Okay, so we figured out when to multiply and divide. But what happens when we start throwing negative numbers into the mix? This is the second key to our code, and trust me, it's way simpler than you might think. First, just a super quick refresh. Integers are just whole numbers. They can be positive, negative, or zero. Think of a thermometer dropping below zero, owing money on a credit card, or your elevation being below sea level. These aren't just some abstract math ideas, they're all around us in the real world. So why does a negative times a positive equal a negative? I mean, it feels weird, right? Well, imagine you're standing on a staircase at ground level. That's our zero. A negative number, like -2, means you go down 2 stairs. Now, if you do that 3 times, where do you end up? You're 6 steps below where you started, right? At -6. And that's a really simple way to picture why -2 times 3 is -6. Let's look at the overall pattern here. When the signs are the same, so a positive and a positive, or a negative and a negative, what happens? The result is always positive. But what about when the signs are different? One positive and one negative? Well, the result is always negative. You know what? Let's boil that down even more. This is the only rule you need to remember for signs when you're multiplying and dividing. If the signs are the same, your answer is positive. If they're different, the answer is negative. That is it. And here's a fantastic little shortcut. If you've got a long string of numbers all being multiplied or divided, just count the negative signs. If there's an even number of them, like 2 or 4 or 6, your final answer will be positive. If there's an odd number, it'll be negative. It's a great way to check your work before you even start calculating. Okay, so we've got 2 keys on our keychain, but how do they work together? What happens when you've got multiplication and negatives and subtraction all in the same problem? Well, you need a master key that tells you the correct sequence. And that key is the order of operations. You might have heard of this as PEMDAS, or BEDMAS. It is the official rulebook for math. You always handle brackets first, then exponents. Now, here's the part that trips a lot of people up. Division and multiplication are a team. They're equals, so you just solve them as they appear from left to right, just like reading a sentence. The exact same thing is true for the final team. Addition and subtraction. This looks super simple, right? But believe me, this is a classic trap. Does the multiplication come first, or do you just work your way across? The order here is absolutely everything. A lot of people think the M in BEDMAS means you always have to multiply before you divide. If you do that here, you'd get 6 times 5, which is 30. Then 36 divided by 30 gives you 1.2. This is probably the most common mistake, and it's completely wrong. Remember, multiplication and division are partners. You just solve them from left to right. So the first operation we run into is division. 36 divided by 6 is 6. Then we multiply by 5 to get the correct answer, 30. See the difference? The rulebook really matters. So we have them, all 3 keys. The key for choosing the operation the key for handling the signs and the master key for the order. It is time to go back to our original puzzle and crack this code once and for all. Here it is again. It might still look a little intimidating, but now we have a system, we've got a plan. We just need to follow the rules of BEDMAS, one step at a time. Okay, first up is B for brackets. We see that 9 minus 2 right at the end. Well, that's easy, it's 7. The rest of the expression just has to wait its turn. Next is multiplication and division. And remember, we're moving from left to right, so the first thing we see is -2 times 3. A negative times a positive is a negative, so that gives us -6. Then, moving across, we see 14 divided by 7, which is 2. Let's plug those new numbers back in. But we're not done with multiplication and division yet. Looking at our new line, we still have -6 divided by 6. A negative divided by a positive is a negative, so that gives us -1. And look at that. All we have left is some simple addition and subtraction. And now for the last step, addition and subtraction. Again, from left to right. We start with -1 plus 9, which gets us to 8. That just leaves us with 8 minus 2. And there it is. The final answer is 6. That whole chaotic mess of symbols and numbers, when you actually apply the system, it just boils down to the simple number 6. We've cracked the code. So in the end, it was never a secret code full of arbitrary rules at all. It's a system with a clear logic and a clear order. And that makes me wonder, what else in our lives that feels chaotic and confusing is really just a system we haven't taken the time to understand yet?